Functions. Let's talk about functions. Let's talk about functions. Let's talk about functions. Guys, that was just me being me. Welcome to everyone watching. In this lesson, we will be looking at functions. So grab a pen and your workbook and let's meet on the other side of the intro. Before we begin, I'm so excited to give a special shout out to all my year 11s who recently got their GCSE results. Guys, I'm so proud of you for doing exceptionally well and totally smashing those exam papers. Your hard work has paid off, and though I may not see some of you again, you will always hold a special place in my heart. And I'm confident that you will go on to do amazing things. Thanks to those of you who have let me know how instrumental this channel was in helping you to prepare for those exams. And thank you so much for sharing the content with others. Now, on to our topic for this lesson. So in this lesson, I'll be presenting it in 4 sections. Section 1 will be an introduction to functions. Section 2 will be composite functions. Section 3 will be rearranging formula. And our final section, section 4, will be on inverse functions. Guys, these lessons are also geared to help you to have an advantage in mastering your GCSE curriculum. So it's very important that you continue to follow me on this math journey, and soon it will be you celebrating your maths results. Now guys, we will begin with defining a function. A function is a special relationship among inputs, which we call the domains, and their outputs, which we also call the codomain, where each input has exactly one output and each output can be traced back to its input. Very important here to note that every input has exactly one output. Therefore, if an input has more than one output, we do not have a function at all. Now, in a function, the input or the domain is what goes into the function. It is also called an independent variable, which means it doesn't depend on anything. It's always itself. You'll see where that comes in a little bit more. Now, we're now going to look at the different types of function. Now, I know that you know lots of functions. However, because the name function hasn't necessarily always been attached to them, you don't know that you know them. But let's prove that you do know at least some of them. So the first type here is a linear function. Now the word linear comes from the word line. So whenever we draw a linear function, we always get a straight line. These are always in the form y equal mx plus c. So here I've cited an example, y equal 2x add 5. So once you do not see a power at all, power meaning a little index, then we know we have a linear function. So next we have the quadratic function. Now if you've watched the previous uploads on expanding double brackets, you would have done a little bit more in depth on your quadratic function. Now your quadratic function always has the highest power of 2. So here in my example here, I've got y equal 2x plus 2 x squared plus 2x add 3. Now you can see the highest power is a square. Whenever we've got that, then we've got a quadratic function. And they could also be negative or positive functions for all the ones that we're doing. Next we have the cubic function. As well, I've looked at this a little bit more in depth when I did the video on expanding triple brackets. So once we expand a triple bracket, the result is always a cubic expression. Now the cubic expression, the highest power has to be a 3 or a cube. So here in my example, y equal x cubed minus 2x squared plus 5x minus 1 is an example of a cubic function. We go on to look at the reciprocal function. So the reciprocal function is always in the form y equal 1 over x. And here it's always fractional. So once we see this fractional expression in the form y equal 1 over whatever letter, what if it's not x? It is a reciprocal function. We also have a circular function, and that one's quite a little giveaway because it has the word circle kind of interwoven in the word circular. So this basically is the equation of a circle, and I've done a complete video on equation of circles. So I've got y equal x squared plus y squared equals 16, an example of a circular function. And we also have our exponential function. So y is equal to 2 to the power of x. So in the exponential function, you will have your variable to be the power. So we're going to move on next to look at what they look at diagrammatically and see if you could identify which function. So if you wrote this down, make sure that you do. Now you could sketch the diagrams beside each of them that you have written down. So identifying function. So what is the name of the function shown below? So the first one here, we've got a. This one is our exponential function. Where is this applied to? So businesses use this to look at growth of stocks and stuff. So you can see stock market rising, and so to know that your business is actually doing very well. For the next one, kind of a bit of giveaway because you got a circle there. So this one is our circular function. And for the other one, you can see a reflective property going on here. So this one is our reciprocal function. Now we look at these two. So the first one here is our quadratic function. Now the shape that's formed here is called a parabola. Now our parabola could also have been inverted the other way. So if we've got a negative and a positive parabola, the orientation of the curve will be different. In this case, this parabola goes down, and that one is a positive quadratic. I know it sounds absurd because you would have thought that it projects or propels to the negative direction. However, it is a positive. And for the next one, finally, it is our cubic function. And we could also have positive and negative cubic functions as well. Beautiful. So with that foundation being laid, we're going to now look at function notations and how do we read them. So rather than writing, for all the examples we did, we wrote y equal to something. So rather than writing y equal to, in a function notation, we use fx, but it doesn't have to be x. Any letter at all could be used. Therefore, we read it as f of x. So whenever you see what's here, fx, we read it as f of x. So if we use another letter, for example, g and h, you'll call it g of x, h of x. What does this mean? So remember, in our linear function, for example, we said y equaled 2x add 3. We could write that as f of x equal 2x plus 3 instead of using y. It's really that simple. So the f of x just simply takes the place of y, and it indicates that we've got a function. So think of this as an output for a given value of x, and we're going to qualify that now by looking at some examples. So whatever input we're given, it is going to produce a corresponding output after we've done our substitution of that value. So let's get a little bit more closer on manipulating our functions. So in order to manipulate functions, we rely on our substitution skills. We do that in our introduction to algebra. So this is where we replace letters for numbers in expressions to find the exact value. So everything in mathematics is intertwined, guys. We've got to make sure that we're good at our substitution skill because we need that for our functions as well. So here we go for some examples. In this example, we're given that f of x is equal to 3x minus 7, what is the value of the following? So we're going to do these examples here. So first one for part A, ask us to find what is f of 4. Remember, we read f of x. Now that x is replaced by 4, so we are asked to find what is f of 4. What this simply means is that where x is in our function that we're given, we should replace that x with 4. So what I'm going to do first of all is to rewrite the function here. So I've got f of x is given to be 3x minus 7. We want to find f of 4. So all we need to do, where x is in our function, we're going to replace that with the 4 that we're given. So we do 3 bracket, always put in bracket what you're substituting, 4, and then minus 7. So we're just going to now calculate. So 3 times 4 gives us 12, and then 12 take away 7 gives us 5. So the answer is that f of 4 is equal to 5. There, we've got it. Really that simple. So substituting. For the next one, we are asked to find what is f of minus 5. So we're going to do f of minus 5, and that's equal to, I'm going to replace the x again in the function. So 3 bracket minus 5 minus 7. Then we work it through. So 3 times minus 5 gives me minus 15. And minus 15 minus 7 is equal to minus 22. And that's our final answer. We go on to the next question. Part C asks us to find f of 9, but we need to add 2 to that result as well. So f of 9 add 2. So f of 9, let's find that first of all, is equal to 3. So writing the same function, bracket, we're replacing x with 9. And then we're going to need to add 2. So I'm just going to leave the addition first. So 3 times 9 is 27. So that is f of 9. So f of 9 plus 2 will be equal to 27 add 2, which is equal to 29. And finally, this time we need to find f2f of 6. So what we're going to do is to break this down first of all. 2f of 6 means that we are doing 2 multiplied by whatever is f of 6. So we're going to find f of 6 first of all, and then we're going to multiply that by 2. So f of 6 is equal to 3 times by 6. So we're substituting 6 for x, and then minus 7. So 6 times 3 is 18. Minus 7 leaves us with 11. So now we need to do that multiplied by 2. So 2 of f, or 2f, is equal to 2 times by 11. And the final answer there is equal to 22. So for a beautiful example there, this is really simple because it's just basic substitution. So make sure you write your examples and work along. So I'm going to do these final examples here, and then it's time for our key takeaways. So here we're given this time 2 functions. G of x is equal to x plus 5 all squared, very important to note there, and f of x is equal to 2x squared minus x. We're asked to find the value of part A, g of 3, part B, h of 4, and part C, g of minus 9. Very important here, guys, we have to remember to use BIDMAS. Remember, we follow the order of mathematical operations. So I'm going to go ahead and do g of 3. So g of 3 is equal to, I'm going to rewrite this. So I'm going to replace my x here. So let's just write this first. X plus 5 squared. Now I'm going to substitute for x3. So instead of x, that's 3, add 5 squared. Importantly, we've got to do the brackets first. So 3 add 5 is 8. So essentially we're doing 8 squared, and 8 squared is 64. And that's our final answer. Then we move to h of 4. So here is our function h of x. So again, I'm just going to write the function out, 2x squared minus x. Importantly for this one, you must replace x wherever x is. So now we've got two x's, so we need to replace these x's with the 4. So h of 4 is equal to 2 bracket 4 squared minus 4. So order of operation, we need to do our square first. So 4 times 4 is 16. 16 times 2 is 32. So we're doing 32 minus 4, which gives us 28. So the final answer there is 28. Now for our final example, we're doing g of minus 9. So we've got for g of x, so g of x is equal to x plus 5 squared. So now I'm going to substitute. So g of minus 9 is equal to minus 9 plus 5, put that back in bracket, all squared. Take care of my bracket first. Minus 9 plus 5 is minus 4. So essentially, I'm squaring minus 4, which means minus 4 multiplied by minus 4. So two negatives here will give me a positive. So 4 times 4 gives me 16. So that is our final answer. Absolutely brilliant. Make sure that you practice this some more, and also remember there are additional questions that you will have to do for your independent practice. Now, it's time for our key takeaways. So first of all, we talked about the fact that a function is a special relationship among its input and output, where each input has exactly one output. We said that we have several different types of function. We talked about our linear function, we talked about our quadratic function, talked about our cubic function, we talked about our reciprocal function, our circular function, and also our exponential functions. Now there are many things that we could do with functions, and so in the other parts of this lesson you will learn about things like composite functions, inverse functions, and so on. Absolutely brilliant. So that's what our basic foundation on function, what it is, and how we can find simple answers to function by just completing some substitution. I hope that by now you have subscribed to the channel, guys. You've hit the notification bell so you see everything that comes off from this channel. Very important, as all of these function lessons are linked to each other, very important to watch them in the order that they come. Share them so your friends also benefit from that, and also remember we are on TikTok where we'll do further exam style questions. Guys, thank you so much for watching.